Now let us see about the work done during an isothermal change. Now let us consider the indicator diagram. Indicator diagram means the graph of pressure against volume. The gas changes its state from the initial value A P1 V1 A P1 V1 to the final value B P2 V2. A is the initial state of the gas and B is the final state of the gas here that we can consider here. The gas changes its state from A P1 V1 to B P2 V2 there. Lakshat, now here we have to find out the work done. आता work done चा basic formula तुम्हाला माहिती आहे. Work done is equal to force into displacement. हा बेसिक फॉर्म्युला झाला त्याचा. त्यानंतर आपण डिराइव्ह केलेला आहे work done during the expansion or compression of the gas. That is, in the case of the gas, when the gas changes its state, the work done is given by dW is equal to PdV. Now see here, for the small change in volume dV, इथे आपण कन्सिडर करू शकतो या ठिकाणी समजा. Here the pressure suppose almost remains the constant, that is P. The pressure almost remains the constant for the small change in volume dV. And in that case, the work done is given by dW is equal to PdV. dW is equal to PdV. Now here, the gas changes its state from V1 to V2. The gas changes its state from V1 to V2. Now in that case, the work done can be obtained by W is equal to integral of dW from initial volume V1 to final volume V2 here. The work done dW is equal W is equal to integral of dW and the volume changes from V1 to V2 here. That's why the integration limits are V1 to V2. But dW is equal to PdV. We can put the value of dW here, and that is why we can write here integral of PdV, integration limit V1 to V2. Now we know that ideal gas equation, समजा आता आपण याला equation number 1 म्हणू. Ideal gas equation for 1 mole that we write here PV is equal to RT. आपण 1 mole of gas consider करू या ठिकाणी. Differentiating this equation. या equation ला आपण differentiate करू. Differentiating this equation PdV plus VdP is equal to RdT. असं आपण कन्सिडर करू शकतो. PdV plus VdP is equal to RdT. असं आपल्याला कन्सिडर करता येईल या ठिकाणी. किंवा सॉरी 1 minute. There is no need to differentiate this equation. Simply we can find out the value of P from this equation. That is, we can write here P is equal to RT upon V. P is equal to RT upon V. V हा आपण right side ला shift केला. And therefore, we get here in equation 1. What is equation 1? That is W is equal to integral of PdV. आता P ची व्हॅल्यू आपल्याला या इक्वेशन वरनं टाकायची आहे. That is RT upon V into dV. ही P ची व्हॅल्यू झाली या ठिकाणी. इंटिग्रेशन लिमिट V1 to V2. Integration limit is from V1 to V2. But R and T are constant because it is the isothermal change, hence the T is constant. R is the gas constant. त्यामुळे आपण RT ला बाहेर काढू शकतो. We can take RT out of the integration sign here. And that's why integral of dV upon V. Integration limit V1 to V2. That is equal to RT integral of dx upon x. Integral of dx upon x. That is equal to log x. हे माहिती आहे आपल्याला. त्यानुसार इथे काय येईल? RT log of V. RT log of V. And integration limit V1 to V2. And therefore we can write here it is equal to RT into log of V2 minus log of V1. Log A minus log B. Log A upon B. असं लिहू शकतो आपण. That we can write here RT log of V2 upon V1. W is equal to RT log of V2 upon V1. पण हा जो लॉग आपण इथे कन्सिडर केलेला आहे त्याचा बेस किती आहे? त्याचा बेस आहे E. आपण जनरली लॉग हा 10 बेसचा यूज करतो. लक्षात. अँड देअरफॉर वी कॅन हॅव द कन्व्हर्शन. तुम्हाला माहिती आहे लॉग ऑफ x is equal to 2.303 log of x to the base 10. Therefore, we can write here final relation W is equal to काय लिहिता येईल? 2.303 हा RT as it is. याचं कन्वर्शन केलं आपण. हा log to the base E आहे. This is the log to the base E. आता आपल्याला log to the base 10 मध्ये त्याचं कन्वर्शन करायचं. म्हणून आपण त्याला 2.303 ने मल्टिप्लाय केलं. And that is we write here log of, बघा हा log LOG लिहिला मी, हा LN लिहिलेला आहे. Log of V2 upon V1. इथे याचा बेस किती आहे? 10. लक्षात. Therefore, this is our expression. W is equal to 2.303 RT log of V2 upon V1. This is the expression for work done by the gas during the isothermal change. Work done by the gas during the isothermal change. Now see here, when the gas expands, means V2 is greater than V1. V2 is greater than V1. In that case, work done is positive. When the gas expands, V2 is greater than V1, then work done is positive. When the gas compresses, when there is a compression, then V2 is less than V1, and in that case W is negative. In that case W is negative. त्यावेळेला W ची व्हॅल्यू ही निगेटिव्ह राहील. लक्षात. समजले? वर्क डन by the gas during the isothermal change. This is the formula here. W is equal to 2.303 log RT log of V2 upon V1. तुम्ही याला वेरियस फॉर्म मध्ये सुद्धा लिहू शकतात by using the ideal gas equation. PV is equal to RT. P1 V1 is equal to RT घेऊ शकतात तुम्ही. लक्षात. आणि त्याच्यावरनं मग तुम्हाला वेरियस फॉर्म मध्ये इक्वेशन लिहिता येईल. You may try this yourself. Write this equation in different forms. Now let us see about the adiabatic relations. Adiabatic change आपण कशाला म्हणतो? Adiabatic change means when there is no exchange of the heat. When there is no exchange of the heat, that means dq is equal to 0. हे आपल्याला माहिती आहे. dq is equal to 0 for the adiabatic change. Now we have to study the adiabatic relation. जसं आपण PV is equal to RT स्टडी केलेला आहे बघा. त्याच पद्धतीने adiabatic relations मध्ये PV isothermal change मध्ये PV is equal to constant. Now similarly we can see the relations in case of adiabatic relation. Now consider 1 mole of the perfect gas. Consider 1 mole of the perfect gas. It changes its state. It undergoes the change in the state. It undergoes the change in the state. It may absorb or it may changes its volume as well as pressure. Suppose here temperature may also change as it is the adiabatic change here. Now here suppose we can consider du is the change in the internal energy. Du is change in internal energy. dW is external work done. dW is the external work done. And suppose dq is the amount of heat absorbed or given out. Then according to the first law of thermodynamics, first law of thermodynamics known to you, that is dq is equal to du plus dw. dq is equal to du plus dw. Now here we write this equation for 1 mole of the perfect gas. For 1 mole of the perfect gas here. लक्षात घ्या इथे du काय आहे? चेंज इन इंटरनल एनर्जी. dw external work done आहे या ठिकाणी. dw is the external work done. Now see here, you know that dw is equal to pdv. dw is equal to pdv. हे आपल्याला माहिती आहे या ठिकाणी. dw is equal to pdv. du is the internal change in internal energy. Now suppose when the volume of the gas remains constant, all the energy given should be used to raise the temperature. And according to that relation, du is equal to Cv dt. These are known to us. du is equal to Cv dt. dw is equal to pdv. And this is the adiabatic change. And for this adiabatic change, dq is equal to, for adiabatic change, dq is equal to what? Adiabatic change साठी condition काय आहे? dq is equal to 0. dq is equal to 0. And therefore, suppose here this is equation number 1. We put all these values in equation 1 here. dq ची value आपण 0 टाकू. That is equal to du means Cv dt. Change in internal energy, that is equal to Cv dt, plus dw, that is pdv. dw is equal to pdv. Suppose this is our equation number 2 here. 0 is equal to Cv dt plus pdv. Alakshat. Now we have the ideal gas equation. PV is equal to RT. PV is equal to RT. Yes. Okay, ठीक है. ठीक आहे, 1-2 दिवसात पाठवतो तुम्हाला MCQ. Okay. Now see here, PV is equal to RT. Then we write here P for we can now differentiate this equation. PdV plus VdP is equal to RdT. PdV plus VdP is equal to RdT. P constant ठेवला, V चा differentiation dV plus. Now V constant, differentiation of P, that is dP. That is equal to R. R is constant. Therefore, differentiation of temperature is dt here. Now, from this relation, dt is equal to what? dt is equal to PdV plus VdP, PdV plus VdP upon R. dt ची व्हॅल्यू टाकली आपण, सॉरी dt आपण फाइंड आउट केला. आता dt ची जी व्हॅल्यू असेल ही आपण इक्वेशन 2 मध्ये टाकू. दॅट इज वी राइट हियर here P CV into dt. CV into dt means PdV plus VdP upon R, right? Plus P into, here not dW, here is dV, sorry for it. PdV, CV dt plus PdV. And that is we write here PD. That is to be equal to 0 here. Multiply this equation by R. R ने या equation ला multiply करू. इथला R cancel होईल आणि इथे R येईल. That we write here CV into PdV plus VdP is plus R into PdV is equal to 0. R into PdV is equal to 0. R ने multiply केला आपण या equation ला. हा bracket काढून टाकू आपण. Now we remove this bracket. Then we write here CV into PdV plus CV into VdP plus R into PdV is equal to 0, right? Now here PdV is common from these two terms. Then we write here CV plus R in bracket and PdV is common. The he term आणि he term त्यांच्याऐवजी आपण यातून PdV कॉमन काढला प्लस CV into VdP is equal to 0. Suppose this is our equation number 3. Consider this is equation number 3 here. Now we know the Mayer's relation, that is Cp minus Cv is equal to R. Cp minus Cv is equal to R, and therefore Cv plus R is equal to Cp. Ha minus Cv इकडे जाईल, and therefore we can write here Cv plus R is equal to Cp. ही value आपण या equation मध्ये टाकू. Then we can put the value of Cp, that is Cv plus R is equal to Cp in equation 3. And therefore we can write here Cp into PdV. Cp into PdV plus Cv into VdP is equal to 0. Is equal to 0. Now divide this equation by CV into PV. CV into PV ने आपण या इक्वेशन ला डिवाइड करू. बघा इथे आपण कुठे केली व्हॅल्यू डिवाइड बाय CV into PV. Here we divide by CV into PV. इथे डिवाइड करू आपण CV into PV. That doesn't matter, it is equal to 0. Now see here, in this case, CV get cancelled here. V also get cancelled. In this case, we can have the cancellation for P. This P also get cancelled here. इथे आप P सुद्धा cancel होईल बघा. And then Cp upon Cv. Cp upon Cv is equal to constant gamma, specific heat of constant, that is gamma. And that's why we can write here gamma is equal to, gamma into dV upon V plus dP upon P is equal to 0. Is equal to 0. Now then, we can rearrange this equation. आपण या इक्वेशनला रिअरेंज करून घेऊ बघा आपल्या सोयीसाठी. That is, we write here dP upon P plus gamma into dV upon V is equal to 0. Now integrate this equation. या इक्वेशनला आपण आता इंटिग्रेट करू. इंटिग्रेट केल्यानंतर काय होईल बघा, इंटिग्रल ऑफ dP upon P, इंटिग्रल ऑफ gamma is constant, therefore integral of dV upon V, integral of dP upon P is log of P plus gamma here, इथे confusion नको होऊ देऊ, log of P, gamma log of V is equal to constant. Integrating this equation, then we can write here this equation as log of P plus log of V raised to gamma is equal to constant. आपल्याला एक आयडेंटिटी माहिती आहे, therefore we write here log of V raised to gamma, log of A plus log of B, log of AB, log of PV raised to gamma is equal to constant. Log of PV raised to gamma is equal to constant. And now see here, log of PV raised to gamma is equal to constant means PV raised to gamma is equal to constant. PV raised to gamma is equal to constant. Now this is the adiabatic relation between pressure and volume. PV raised to gamma is equal to constant. जसं isothermal साठी PV is equal to constant for isothermal change. For isothermal change, PV is equal to constant. For adiabatic change, PV raised to gamma is equal to constant. याला आपल्याला various form मध्ये पण लिहिता येईल. That is, you can write here it in, that is PV is equal to RT. आपण P ची व्हॅल्यू टाकायची या ठिकाणी. Then we write here P is equal to RT upon V. P is equal to RT upon V. We put here this value RT upon V into V raised to gamma is equal to constant. R आपण इकडे घेऊन जाऊ, constant divided by R. R is constant, therefore constant divided by constant is constant. T V raised to gamma हा V numerator ला घेऊन जाऊ, gamma minus 1, gamma minus 1. TV raised to gamma minus 1 is equal to constant. TV raised to gamma minus 1 is equal to constant. This is the another relation. मग आता तुम्ही काय करायचं, व्हॉल्यूमची व्हॅल्यू टाकायची या रिलेशन वरनं, म्हणजे V is equal to RT upon P. या इक्वेशन मध्ये V is equal to RT upon P put up करा, and then you will get the relation between pressure and temperature. मग तुम्हाला प्रेशर आणि टेम्परेचर यातील रिलेशन मिळेल. The relation that you get here, T raised to gamma upon p raised to gamma minus 1 is equal to constant. हे तिघही रिलेशन्स महत्वाचे आहेत बघा. pv raised to gamma is equal to constant, tv raised to gamma minus 1 is equal to constant, t raised to gamma upon p raised to gamma minus 1 is equal to constant. These are the adiabatic relations. यांना आपण adiabatic relations म्हणतो.